Hello and welcome back to your sixth intermediate tutorial. Today we will be talking about multi-threading. Multi-threading is probably one of the most important concepts in this entire series. So let's go ahead and let's start that. So 06 multi-threading. So alright, so let's go into the actual definition. Thread. So by definition, multitasking is when multiple processes share common processing resources, such as a CPU. Multithreading extends the idea of multitasking into applications where each of the threads can run in parallel. The OS divides, the idea of multitasking into applications where you can subdivide specific operations within a single application into individual threads. Each of the threads can run in parallel. The OS divides processing time not only among different applications but also among each thread within an application. Multithreading enables you to write in a way where multiple activities can proceed concurrently in the same program. So that was the definition of it. It was from this website. I didn't cite it in the comments of this code right here, so because I'm stupid. So, but whatever. Okay, so that was that. So basically, what it means is, when you're running a program, you're running it from top to bottom, starting at the main, right? And that is one thread. And when one thing happens, the next thing happens after that. And so if something takes a long time to happen, the other thing has to wait. So a good thing about multi-threading is you can have multiple things, multiple processes, so happening at the same time. So if one thing takes too long in one thread, it won't slow down the other thread because it's happening independently of that. So let's actually go ahead and let's make our package. We're actually going to make two examples in this tutorial. So we're actually going to have some different packaging. So we're going to do tut06, just like we did before, and then we're going to go ahead and make a new package in that package and call it example1. So this will be our first example. So the way we're going to be doing threads, there's two ways to do it. There's an interface for threads and there's a class that you can extend for threads. In both of these examples, where I'm actually just going to use a class, but just be aware there's an interface called runnable, and that's basically a thread. But to make a thread, we're just going to go ahead and extend this class thread. Alright, so name, we're going to call it my thread so that it has a different name. Alright, so now let's go ahead and make some. So this thread right here is pretty much a program. So private string, we're going to call that message, and then we're going to make a private, this is private member. Oh, no, we don't want that. Private int, we're going to do num iterations. Just bear with me, just copy this. Source, we're going to make a constructor using fields. Bam, bam. Alright, so that will be our constructor. Alright, so now what makes this a thread? Let's go ahead and go in here. You can do control space and it'll be right there. So hit control space and do this run method right here. Or you can do source override implement methods and you can look for it here. It's not there anymore because I already overwrote it, but that's fine. So let's go ahead and do for int I. So this thread is going to print out that message the amount of times that we put in number iterations. So this is going to be a simple for loop, sys out message. Okay, so we're going to have multiple threads that use this. So one thing that you need to do is you have to make the thread sleep. So usually when you have a thread, especially with a loop, after the iteration of that thread, you call this sleep method. And we're going to just catch exception e. We can just do an e.print stack trace. Alright, so what this does essentially is it tells it to wait 50 milliseconds. This is just so it runs quickly. You can make this, whatever, 5,000, that makes it 5 seconds, half second, and this is 0.05 seconds, so I don't know exactly what that is, but whatever. So yeah, and it's going to wait, and that pretty much allows other threads to kind of do things, because you don't want to be stuck in this for loop. So you want it to wait, and this allows other threads to start while this thing is running. You'll see why in a second. Let me just comment this out for now. Okay, so now let's make a main with a main string args. So yeah, I'm just gonna, oops. Let me call this main 1 actually. So hit Alt-Shift-R on main, call it main 1. Oops, no, not that. Main 1 with a capital L. There we go. Continue. Alright, so now let's make a my thread. Let's make 2 threads, so T1, T2. T1 equals new my thread, and we're going to give this hello from thread 1, exclamation point, number of iterations, so make this one iterate 3 times, and let's call T1.start. Alright, now let's run this. So hello from thread 1, I called that 3 times. Let's do T2 equals new my thread, and we're going to do hello from thread 2. And let's have this iterate 5 times. So let's see what happens. Oh, I didn't call T2.start. Alright. So, okay. Well, first of all, this happened before this. So they ran in parallel, but they didn't wait for it. They stopped. They didn't allow the other one to do anything. So this is why we call this sleep method. It allows other threads to work at the same time. So you always need a sleep. And I have 50. You can have it, be that 5 seconds, and it will only do it every 5 seconds. As you can see, wait for it. There it is. So let's stop that because we don't want to wait that long in a video. So that's the thread. So these run in parallel. So as you can see, they don't wait for each other, and the order that they happen is not necessarily set. So you have 2 1 1 2, all right, and then we have a 1 2 1 2, and then we have 1 2 1. Oh, that one's almost the same one. 2 1 2 1. They're different because they're running at the same time. They're not running after each other. So this T.start pretty much opens up a new process in your CPU. So you don't want too many threads. You don't want to be hogging the CPU because that's just not good. So you don't want to be hogging the CPU. That's a very important thing. But usually you want threads. All games work with a thread. So now I'm going to teach you guys what's a game loop. A game loop, or a program loop, is basically it's an infinite loop essentially that only gets closed when you quit the program. And it runs in a separate thread as the main program. So in main, it's actually going to start a new thread so that you can do other stuff with the program and not get stuck in that loop. So let's actually go ahead and make a new package. Let's call it example2. All right, and then we're going to make 3 classes. So first thing we're going to do is we're going to make a very familiar looking class, game. Now you guys remember this class, right? So let's finish that. So we're going to make a simple game where the player is going to put in a number from 1 to 10, and the computer is going to pick a random number, and if the player put the same number, they win, and if they don't, they lose. So we're actually Boolean run. So if you remember in libgdx, we actually didn't have this kind of Boolean run here, but that's because this game would have extended something else. But this is pretty much the basic of how a game works. So scanner, let's just have everything that we want for our game, and let's make our random for our random number generator. I don't think I ever taught how to actually use the random class because we use math.random, but that's fine. I'll show you guys in a second. So let's just first make a simple constructor, a very, very minimalistic one. So this.run equals true. So it's going to start running it's going to be true when you first open it. So now let's make the methods that look familiar. Create, right? And then I'm going to name it update, not render, but update, right? And public void dispose. All right, and then here we do in.close Alright, so let's actually, before we do that, let's go ahead and just do system out here. I am called before the game loop. And then let's do sysout I am called after the game loop. Alright, so now we do in.close. So that's nice for our dispose method. We have a little place to close our input, which, because it's a resource. So let's instantiate everything, new scanner. So it looks a lot like our libgdx games. You know, we instantiate up and create system.in. This is how those kind of frameworks work. That's how libgdx works. It opens up this thread. Okay, so in our update method, this is going to be called at, you know, it's not going to be called 60 times a second because it relies on user input and all that. But yeah, so let's do int computer equals r.nextInt. So what this method does is it chooses a random number between 0 and 1 minus this number. So it can be either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So to make this from 1 to 10, we just add 1 to it. So if this chooses a 0, it'd be a 1, and if it chooses a 9, it'd be a 10. So that's just a simple way to do it. Int player, we're just going to declare that variable. Sysout enter a number from 1 to 10, 0 to quit. Alright, so player equals in.nextInt. Okay, so if player is equal to 0, run is equal to false. So this is I remember in libgdx you do, you know, gdx.app.exit. It pretty much does that. It tells it to get out of the game loop. So else, now we want else if player is greater than or equal to 1 and player is less than or equal to 10. So if they enter a number between 1 and 10, then it's going to play the game, and if not, it's just going to go back to here. So if player is equal to computer, sysout you guessed right, and else, right now we're just building a simple game, sysout you guessed wrong, and we're gonna just concatenate we could do a string format, but I'm not going to. The answer was, and then plus computer, just so that they know that they feel right, or that they feel bad about, you know, not getting that number even though it's completely random. So, alright, so we have this little game. Now, we can't run this, obviously, and even if we were to just do, in main, just do new game, game.create, game.update, game.dispose, this would only run once. So, let's make a thread. So, let's go ahead and make a new class, and let's just call this game thread. And then we're going to do thread. Alright, so let's go ahead and just give it a game G. And then we want to generate a constructor using fields, so G. Alright, and then let's just go ahead and override run. And actually, let's just go ahead and call this.start. Just so that you don't have to call it every time, because we know when we make a game thread, we're going to run a game. So let's go ahead and do that. So, alright, so g.create. So while g.run, so as long as g is true, so as long as this does not get called, this will always run. g.dispose. Alright, and g.update. So this gets called before the loop, this is during the loop, and this is after the loop. So now if we have our main class main2, let's go ahead and just do it's not going to override it or extend anything. Sorry, I just like dozed off there. Not dozed off. Spaced out. So new game thread. New game. All right. So, oops. Is it spelled wrong? Change to game. Oh, it's spelled wrong here. Thread. There we go. Okay, so now let's just use this out after init. And as you can see, after init does get called. Let's do 0 to quit real quick. After init does get called, but if we were to say, put this here and comment this out, comment that out, put that down there, after init does not get called until after the game is called. So if you want other things, like say you have a launcher, which we will have, and you want it, to close the launcher after the game opens, something like that, you want it there. It's always good to have the game itself on a separate thread. That's why I'm teaching you this. And also, we're not doing a sleep here, but like say if you want to like lock the frame rate, what people do is they can calculate how much time this while took, and then this while loop, so they pretty much get the time at the beginning and subtract it from the time at the end, and then they calculate the difference between that and 1/60th of a second, and then if it's greater than, like if 1/60th of a second is greater than the amount of time that it took, it actually sleeps so that it can always be at least 1/60th of a second at each iteration of this while loop, so that it is locked at 60 frames per second. That's just a little interesting thing about how games work, the mechanic, the actual development of it. So enter a number from 1 to 10. So, let's do 4. Oh, I guessed wrong. The answer was 2. Let's put in 2 again. Oh, it was 6. Let's put 4. And it's going to keep playing until I guess right. There we go. I guessed right. There we go. 4. Alright. And if I put in like a whatever H, it actually throws an exception. So input mismatch exception. We could, catch that exception, but I don't want to. Let me put in a incorrect, something that doesn't work. -24. It doesn't do anything. It just goes back to enter a number. Okay, I am called after the game loop. I am called before the game loop. So it was created. I'm called before the game loop. Right here, it was created. All this started, and in dispose, it was put. It was closed as it should be. It's a resource. So that's all I have on threads for now. Yeah, they're really important. So yeah, you really need to know this concept. Rewatch this video over and over and over if you don't get it, and do your own research. Do a lot of research on your own so that you can really understand how threads work, because they are one of the most fundamental concepts of building a complex program, or pretty much any usable program. So that is it, and yeah, thanks for watching and have a great day. Bye.